Section 14.2, Quadratic Equations, Completing the Square. The objectives: solve quadratic equations by completing the square. Example 1, add the constant that will complete the square for each expression and write the new expression as the square of a binomial. In order to do that, we're going to find half of the coefficient of x and square the result. We're going to add this square constant to complete the square. The resulting trinomial will equal the square of a binomial. X squared plus 10x plus some number is going to equal some quantity squared. We're going to take half of our x term. The coefficient there is 10. 1/2 of 10 is 5. And then 5 squared is 25. And that's what we're going to put. We're going to add 25. X squared plus 10x plus 25 ends up factoring into x plus 5, that quantity squared. Example 1b, x squared minus 7x. Once again, x squared minus 7x plus what quantity squared is going to equal a binomial squared. We're going to take 1/2 of negative 7, which is going to give us negative 7/2. And we're going to square that. Negative 7/2 squared is 49 over 4. So add 49 over 4. That becomes x squared minus 7x plus 49 over 4, which will factor into x minus 7/2, that quantity squared. To solve a quadratic equation by completing the square, step 1, if necessary, divide or multiply on both sides of the equation so the leading coefficient, the coefficient of x squared, is 1. Step 2, if necessary, isolate the constant term on one side of the equation. Now that's different than what we've done in the past. Step 3, find the constant that completes the square of the polynomial and add this constant to both sides. Remember that the constant term is the square of 1/2 of the coefficient of x. Rewrite the polynomial as the square of a binomial. Step 4, use the square root property to find the solutions of the equation. Example 2, solve by completing the square. X squared minus 8x equals 25. So for our solution, the coefficient of x squared is already 1, so we can ignore step 1. And the constant is isolated on one side of the equation, which means we can ignore step 2. So moving to step 3, we're going to complete the square by taking half of the constant on our x term, which is half of negative 8, which is going to give me negative 4. And then we're going to square negative 4, which is going to give us 16. And we're going to add 16 to both sides. So that gives us x squared minus 8x plus 16 equals 25 plus 16. The left-hand side then becomes x minus 4, that quantity squared, equaling 41. Now we'll simply take the square root of both sides, which leaves us with x minus 4 is equal to the square root of 41, or x minus 4 is equal to negative square root of 41, which means our solution for x is equal to 4 plus the square root of 41, and x equals 4 minus the square root of 41. There are two real solutions, 4 plus the square root of 41 and 4 minus the square root of 41, and we can actually write that as x equals 4 plus or minus the square root of 41. Example 3, solve by completing the square. 3x squared plus 6x minus 15 equals 0. So here we need to make sure that we have a coefficient of 1 on our leading coefficient. So we're going to have to divide everything by 3. That's every single term on the left and on the right. That's going to leave us with x squared plus 2x minus 5 equals 0. Now we're going to move the constant term to the right by adding 5 to both sides. So now we have x squared plus 2x equals 5. And then we're going to add 1 to both sides because 1/2 of 2 is 1 and 1 squared is 1. So we have x squared plus 2x plus 1 equals 5 plus 1. And again, we completed the square by taking 1/2 of 2, which was 1, and squaring that, which was still 1. The left side factors into x plus 1, the quantity squared, equals 6. Now we'll take the square root of both sides. X plus 1 equals plus or minus the square root of 6. Subtracting 1 from both sides, x equals -1 plus or minus the square root of 6. Example 4, solve by completing the square. 2x squared plus 2x minus 7 equals 0. So for our solution, we're going to start by dividing each term by 2 so that the leading coefficient will be 1. That gives us x squared plus x minus 7/2 equals 0. Now we're going to isolate the constant term by adding 7/2 to both sides. So we have x squared plus x equals 7/2. Now we're going to add 1/4 to both sides. Again, to complete the square, you take the coefficient of x, which is 1, and you multiply it by 1/2. 1/2 of 1 is 1/2. Then you square that number. 1/2 squared is 1/4, and you add it to both sides. Then the left-hand side is going to factor into x plus 1/2, that quantity squared, equaling 15 over 4. Taking the square root of both sides, we end up with x plus 1/2 equals plus or minus the square root of 15 over 4, which is x equals -1/2 plus or minus the square root of 15 over 2. We got to this step by subtracting 1/2 from both sides and recognizing that the square root of 4 was 2. So our solution is x equals -1 plus or minus the square root of 15 all over 2. Example 5, solve by completing the square. X squared minus 2x plus 13 equals 0. Our leading coefficient is always 1, or already 1, so we can skip step 1. We do need to isolate the constant term by subtracting 13 from both sides. That gives us x squared minus 2x equals -13. And we're going to complete the square by taking 1/2 of -2, which is -1, and -1 squared is 1. And we're going to add 1 to both sides. That gives us x squared minus 2x plus 1 equals -13 plus 1. Then the left side factors into x minus 1 squared equals -12. Taking the square root of both sides, x minus 1 equals plus or minus the square root of -12. X minus 1 equals plus or minus I square root of 12, which is equal to plus or minus 2i square root of 3, because 12 breaks into the square root of 4 times the square root of 3. Now we're going to add 1 to both sides. X equals 1 plus or minus 2i square root of 3. This time the solutions are non-real complex conjugates. This time we're going to complete the quadratic equation by completing the square. 2x squared minus 12x plus 2 equals 0. And it's going to walk us through the steps. So 2x squared minus 12x plus 2 equals 0. So the first thing that they've done here is they have subtracted 2 from both sides. So that first blank is going to have a -2 in it. To get to the next step, they've divided everything by 2. So x squared minus 6x equals -1. Now we're going to complete the square by taking 1/2 of -6, which is -3, and squaring it, which is 9, and we're adding that to both sides. So on the left, we're going to have x squared minus 6x plus 9 equals -1 plus 9. Because you drop the -1 down from the previous step, and we're adding 9 to both sides. This is going to end up factoring into x minus 3 squared equals 8. And then taking the square root of both sides, we have x minus 3 equals plus or minus the square root of 8, And then x equals, we're going to add 3 to both sides, so 3 plus or minus, and 8 will break down into 4 and 2, so it'll be 2 square root 2. So 3 plus or minus 2 square root 2.